we're going to be learning how to actually apply what we've been learning recently in real life situations. Here is a retrieval practice. Make sure to pause your video and give yourself enough time. Okay, I'm now going to move on to the next slide. And I'm going to show you the answer. So if you haven't completed these questions, please do pause the video and answer all the questions. Alright, so here are the answers. Make sure to pause the video and have a good look at all these answers. Okay, I'm now going to move forward. So, when we are calculating upper and lower bounds in real life given situations, they're really, really useful in terms of safety, in terms of safety, weight limits in bridges and elevators, and so on. So they have great usage in real life, and learning this is going to be so helpful for you. So I hope you enjoy it. So here we have a question, and it's asking us to consider the bounds and to work out a value of m to a suitable degree of accuracy. So what you're going to have to first do is find the bounds for each variable. So the lower for s is so on, and the lower for t is so on, and for upper and upper s and upper t. So we're going to work out that first. So that's going to be our very first step. And then we're going to use these bounds to find out the value of m. So if we want to find upper bound for m, we are going to need to use upper s and lower t. Okay, and if we want to find out the lower bound for m, we're going to have to use lower s and upper t, because if you're dividing a number, the bigger the denominator and the smaller the numerator, the smaller the number is going to be. Alright, so now we have both our lower bound m and our upper bound m. So we want to find a single value of m that would be the most sensible, that would be a suitable degree of accuracy to say that this is probably what m should be. So we're going to look at what these two numbers round to, so the upper m and lower m. So saying that m equals 0.229, it would be best because both the lower bound and upper bound are this to 3dp. Okay. So now let's move on to I do, we do practices. So I hope this gives you a feel for what we're going to be doing. So we're going to start off with this question. So what is the error interval for this basketballer's height to the nearest centimetre? Well, firstly, centimetres are 198 centimetres. And we're going to have to find the upper and lower bound for it. So the lower bound for it is 197.5. And the upper bound is 198.5 centimetres. So that means our error interval is going to be this. Okay, so we know that the height has to be between those two lengths. So I want you to pause the video and do the same thing for the we do. Alright, I'm going to go through the answer now. Okay. I am now going to go on to the next slide. Okay, so here we have a real life question. So the length of a pipe is 7 meters to the nearest meter. Complete the error interval for the length of this pipe. Well, the degree of accuracy is a meter. So a meter is worth 1. So what we're going to do is do 1 divided by 2. That gives us 0.5. And to find our upper bound, we're just going to do 7 plus 0.5. And that gives us 7.5. And to find our lower point, we're going to take away from that 7 from that amount. So we end up getting, for our lower bound is 6.5. So therefore our error interval is as followed. Okay, so I want you to try with this question here that we do. So I'm going to keep quiet and I hope you pause the video. Alright, so I'm going to show you the answer now. So this is the answer. So the lower bound is 5.5, upper bound is 6.5. So here we have an actual exam question. So the question says, by considering the bounds, work out the value of V to a suitable degree of accuracy. So our first step is going to be actually working out the upper and lower bounds for both A and B to their degrees of accuracy that they've mentioned here. So upper bound A to 2 decimal places on 2 is in fact 6.435, and the lower bound of A is 6.425. Lower bound, okay, so that's lower bound. So now we're going to do that for B now. So upper bound B to 3 decimal places is 5.5145, and lower bound B is 5.5135. So if we want to find out, upper bound V, we are going to need to use we're going to need to use upper bound A and divide it by lower bound B, and then square root the answer. So upper bound V equals 6.435 divided by 5.5135, and our lower bound is going to be the square root of 6.425 divided by 5.5145. So I'm going to just type that into a calculator and work out the answer for this one. Okay, and if you can actually do it yourself as well to see if I am correct. So I'm going to do the first one. And that gives us 1.08. Okay. And then the next one we're going to do. So you can also do that as well yourself. And that gives us 1.079. Right, so both of them round to 1.08. So that will be to 2 decimal places. So that would be a suitable degree of accuracy. So that would be the answer. So I want you guys to pause the video and have a go at the we do. So have a go at the we do. Okay, I'm now going to go for the answer. So the suitable degree of accuracy would be 2, because they round to 2 to 1 SF. So the suitable degree of accuracy is 2, sorry. So we're going to move on to the next set of questions now. Okay, hello, so we have a question here. So I'm going to read the question out. A sewage tank has a volume of 2,500 litres, correct to 2 significant figures. Nicola empties the tank using a large bucket, which is 50 litres to the nearest litre. What is the smallest number of times she must fill the bucket? And then what is the greatest number of times she must fill the bucket? So with this one, we're going to first find out the upper and lower bounds for the volume and the tank. Okay? So we've done that now. And then the second step is we need to know which is our right combination. So to find out how many times she needs to fill it, she needs to do volume divided by the large bucket. Okay, so how many litres there are in the large bucket, and that's going to tell her how many times she needs to do that. So we need to find the right combination. Okay, so to find the right combination, if she's trying to find the lower bound, she's going to use lower bound tank divided by upper bound bucket. And then here is our answers. So I want you to pause the video and have a go at the next question. It's very similar. Okay, so here's the answer. Right, good job, guys. Right, so here we have these questions. So a formula connecting speed is, well, we know speed equals distance over time. Okay, and we want to find out the upper and lower S. So we need to first things first work out the upper and lower bounds for each of these measurements. So upper D, okay, so upper bound D is 155, and lower bound D is 155, and then upper T is 5.25 and lower T is 5.15. So we want to get if we want to find our upper S, we're going to need to use the biggest value of D and divide it by the lower bound of T. Okay, so that's just going to be 165 divided by, 165 over 7.15. And then if we type that into our calculators, we end up getting 23.07, 08. And then for our lower S, we're going to do 155 divided by 7.25. What we end up getting is 21.38 to 2 decimal places, but the question asks us for 3 significant figures, so this is actually going to be 21.4. Alright, so I want you to try the we do. Okay, I'm going to show the answer now. Alright, I'm now going to be moving on to the next slide. So here we have a question. So it says the dimensions of rectangular 4 are to the nearest 1 meters. Okay. Well, let's say 1 centimeters. Right. And the force of 300 is applied to the floor, and it's to the nearest 10. Work out the upper bound of the pressure. So if we're going to work out the upper bound of the pressure, we're going to need to have the upper bound, force, and lower bound area. So let's first work out the lower bound area. So we need to use the lowest bound for these lengths. So lower bound base is 2.5 and lower bound height is 3.5, and we're going to multiply them together to work out the lower bound area. So 2.5 times by 3.5, that equals 8.75. And now we need to work out the upper bound Newton, so upper bound force. So upper bound force to the nearest 10 is 305. And then that means we're going to use these values now. So it's going to be 305 divided by 8.75. Okay, and that gives us the answer of 34.8624 SF. Right, so have a go at the we do. Okay, so we're now going to go through these answers. So I'm just going to quickly show you how to work out this one as well. So the lower bound for this is just 1.5. Lower bound for that is 9.5. Okay, and then you're going to multiply them together. And that gives you a lower bound area of 14.25. The upper bound force is just 137.5. So you're going to do 137.5 divided by 14.25, and that is going to give you this lovely answer here. Right, so now let's move on to the next slide. So the question is asking us, the maximum load of a elevator is 2,500 kilograms to the nearest 10 kilograms, and average builder is 85 kg, so weighs 85 kg to the nearest kilogram. So we need to work out an estimate of the maximum number of builders that can safely enter the elevator at the same time. So when we are answering this question, let's set it up. We know that the maximum is that, and average is that. So to work out the number of builders that can safely enter, is going to be the upper bound safe load over the lower bound weight. So let's work that out. So the lower bound weight is actually 84.5, and the upper bound, so now we're going to use a calculator to work this out, and we find out that the maximum number that can safely enter is going to be 29.6, and I'm going to round down to 29. So that's the maximum number that can safely enter. Okay, any more than that is not safe, so we have to round down to 29. So 29 builders. So I want you to have a go at the we do question. Okay, I'm going to show the answer now. So it's 20. Right, so the next page is going to be the independent practice. So I do advise you to pause it, because after that I'm going to go quite quickly through the answers. So here is the independent practice. Make sure to pause your video and give yourself enough time to do these questions. Alright, I'm going to go through the answers now, so if you haven't completed the questions, do pause. So here are the answers.